Okay, let's go ahead and take a look at some examples of these complex trig functions and their derivatives. So as we're taking a look at this one, y is equal to x plus cotangent x, we have to refresh our memory here. Cotangent x is equal to cosine x over sine x. And so if you haven't for yourself yet, I have another video that derives the derivative of cotangent. And when you do take the derivative of cotangent, the derivative of cotangent x with respect to x is equal to negative cosecant squared of x. Okay, and so if we wanted to take y prime, first derivative, y prime, we would have to take the sum of derivatives. The derivative of the first thing here, derivative of x is 1. The derivative of cotangent is this negative cosecant squared, so minus cosecant squared x. Okay, if you haven't done this, if you have not found the derivative of cotangent for yourself, give it a try. It is a very good example of using the quotient rule. Okay, now let's try a little bit tougher one. In this case, we have h of theta is equal to 5 theta secant theta plus theta tangent theta. So we've got a lot going on in this thing. All right, let's break it up a little bit. Let's call h1 of theta equals, my equal sign in here, 5 theta secant theta. And the reason for that is we can split this up and kind of chunk it and do a little bit at a time. Let's call h2 of theta equal to theta tangent theta. All right, so now let's find the derivatives of each of these things individually. h1 prime of theta is equal to, this is the product rule. Don't forget that the product rule was the first thing, f of theta, the derivative of the first times the second, plus the derivative of the second times the first. All right, so let's go ahead and continue. We've got derivative of f times g plus derivative of g times f, and so we need to identify our functions. And from this, we're going to identify it as f of theta is equal to 5 theta. I'm going to include the 5 in that. The derivative then of f of theta, f prime, is 5. G of theta is going to be secant theta. Now the derivative of secant is secant tangent. Again, if you don't remember this, go ahead and go back and show and prove it to yourself. Don't just take my word for it. You need to be able to do this in case, God forbid, it happened to be on a test or something like that. So now you don't have a cheat sheet in front of you and you forgot it. Oh no, what do I do? Oh, okay, well just go ahead and derive it. Use your quotient rule. Remember that secant theta is 1 over cosine theta. Okay, and so as we go back through this, h1 prime of theta is going to be the derivative of the first, which is 5, times the second, which is secant theta, plus the derivative of the second, which is secant tangent, times the first. And so I have 5 theta secant theta tangent theta. All right, there we are. And now, if you wanted to, you could pull out a 5 secant. And so you have h1 prime of theta is equal to a 5 secant theta. You have 1 plus theta tangent theta. Okay. All right, so now that was the first one. Let's take a look at the second one. Remember, we split them up. So now we're going to take a look at this second one here. And so we've got, I'm going to erase this identity here kind of give myself a little bit more room so I can have both of them side by side. H2 prime of theta is equal to, and this is f prime of theta. Now we're on a totally separate function here, and so these f's and g's have to be redefined here. G theta plus g prime theta f theta. All right, so going back through and identifying our functions, we have f is equal to theta, f prime of theta is equal to 1, g of theta is equal to tangent of theta. The derivative of tangent is secant tangent, or I'm sorry, is secant squared. Okay. So now that we have that, we can go back through and say, all right, now h2 prime of theta is equal to 1 times tangent theta plus theta times secant squared theta. Okay, now there's really not a whole lot we can do here as far as taking something out. I suppose we could remove a 1 over cosine, but if removing a secant, I don't think is really going to help our cause any. So I'm just going to kind of leave it at that. I might decide to pull it out later because I have a secant over an h1 prime. So, okay, let's wait on it and see what happens. Going back to our original function though, our original function added the two together, and so the derivative of a sum is the sum of the derivatives. And so h, if we have, let me go back to my different one here, h prime of theta is actually equal to h1 prime of theta plus h2 prime of theta. All right, and that is going to equal 5 secant theta 1 plus theta tangent theta plus tangent theta plus theta secant squared theta. Okay, so now let's see what happens. How can I make this look a little bit neater? Out of this group here, let's try to pull out a secant. Secant is, remember, is 1 over cosine. And so I'm going to pull out a 1 over cosine. This gives me 5 secant theta 1 plus theta tangent theta. This gives me a secant theta. And this is now going to be sine theta, because I pulled out the 1 over cosine, plus theta secant theta. All right, so now I can pull out a secant from everything, kind of redistribute that 5 back in. And so I get secant theta. And now I'm going to have 5 plus 5 theta tangent theta plus sine theta plus theta secant theta. And now if you really, really, really want to, you can try to do something with this, but I would just probably leave it. I don't see any particular reason to expand this any further or to factor anything more out. And so I have my h prime of theta. It's secant times 5 plus 5 theta tangent theta plus sine theta plus theta secant theta. It's a mess. Sometimes they're like this. It's okay. Just keep plugging away. Remember to go ahead and break them up when you can. Don't try to do too much at once.